Welcome to the Geometry Unit 7 video for skill number 51. I can use properties of similar triangles and apply properties of proportionality to triangles. We'll begin our notes on page 51A, and we will title it Similar Triangles and Proportional Relationships. Alright, the first proportional relationship we have within similar triangles is the triangle proportionality theorem, which says if you have a triangle ABC, and ABC is intersected with a line that is parallel to the base, so if EF is parallel to BC, then we can say that AE to EB is equal to AF to FC. So if I had a triangle here and I had a line that bisected it, that was parallel. If this was 2 to 6, this would be 1 to 3. Because 2 to 6 is equal to 1 to x. Solve for x, x equals 3. So that's the triangle proportionality theorem. We also have the converse of the triangle proportionality theorem, which is basically this backwards. So it says if you have a triangle where the line intersects it, just like this drawing here, and the proportion is the same, 2 to 6 is equal to 1 to 3, then we are able to conclude that the base is parallel to the line that intersects the triangle. The two are very similar, as all converses tend to be. At the bottom of the page, I've worked through one example which calls upon the triangle proportionality theorem. We have this triangle and it gives us the dimensions and asks us to find x. So very simply, because we know that the base is parallel, we should have a tick mark here, because we know that the base is parallel to the line that crosses through it, we are able to draw the conclusion 2 to 10 is equal to 3 to our unknown distance. So there's the line segments in the proportion, then we substitute the values in and we find that BZ is equal to 15. 2 times 5 is 10, 3 times 5 is 15. Continuing our notes on to page 51b, we have the two-transversal proportionality theorem, or rather it's a corollary, but you might as well consider it a theorem. It states that if you have multiple parallel lines, so we can go 3, we could go 4 if we wanted to, or even 5 parallel lines that are intersected by two transversals, then we can start to draw conclusions about proportionality. Because our lines are parallel, let's draw some tick marks in here, we can state that there's a proportional relationship from this blue section to the red section that is equal to the same over on the right hand side. So in the example 2, I walk us through it. I give us, looks like 4 transversals, or 4 parallel lines cut by 2 transversals. And here's the transversals. I give you the information that AB equals 5, BC equals 6, FG equals 4, and GH equals 8. And what we want to find is EF and CD. So we're looking for EF, right there, and CD. So to find EF, we really only need these 4 portions, AB, BC, EF, and FG. And we can ignore all this stuff at the bottom. So we set up our proportion. AB to BC is equal to EF to FG, and we use that to find our value by cross multiplication, and we find that EF is equal to 26. Once again, we cross multiplied 5 times 4 is 20, 6 EF, and we divide 20 by 6 to isolate EF. Next we want to find CD, and we can ignore the top half of the diagram. Oops, let's undo that. Nope, it won't let me. Okay, we can ignore the top half of the diagram and focus only on BC to CD is equal to FG to GH. And doing so, we can substitute the values in. Cross multiply 6 times 8 is 48, and we get 48 is equal to 4 times CD, and then we divide both sides by 4, and we get 12 is equal to CD. All right, the last theorem in this section of in this skill is the triangle angle bisector theorem. And the triangle angle bisector theorem states that if we have a triangle and we bisect one of the angles, so usually tick marks are shown to show that it's bisected. And let's see, we've got angle B, angle A, D, and C. What we wind up having is a relationship between distances. So this distance here to this distance, AB to BD, is equal to AC to CD. So we might have 5 to 10 is equal to 20 to 40. That relationship 5/10, 20/40. It has a 1 to 2 relationship. On the final page, I'll show an example of the triangle angle bisector theorem. Alright, page 51C. What we have here is we are asked to find distances BC and CD, and they give us a value for them that includes a variable. And it looks as though what we have is a triangle that has one of the angles bisected. These arc marks show us that it's bisected, which means we're allowed to use our triangle angle bisector theorem. And what we can do is we can say AD to BC is equal to AD to CD. And we substitute those values in. 5 goes in for AB, and then 4x plus 3 goes in for BC. 7 goes in for AD, and 8x minus 3 goes in for CD. We now have an equation that we can work at solving by using our cross products property. So our cross product would be 5 times 8x minus 3 is equal to 4x plus 3 times 7. And that's what I've written here. Moving to the next step, I distribute the 5 in, and I distribute the 7 in, which gives me 40x minus 15, 28x plus 21. Finally, I solve that for x, and I arrive at x equals 3. Though the question didn't ask for x equals 3, so I have to go back and see what the question asked for. It says find BC. So we know BC is 4x plus 3, so we can plug that in and get 4 times 3 plus 3, and that has a value of 15. So BC has a value of 15. And then we can plug x in to CD and get 8 times 3 is 24, minus 3 is 21. So our conclusion is that BC is 15 and CD is 21. And we can double check our work and ask ourselves, does 5 to 15 equal 7 to 21? And through the cross products property, we find that to be true. And because it's true, it checks out. Our answer is good. All right, for this skill, there's a couple key ideas and concepts that we need to focus on. The first is the triangle proportionality theorem, which says if I have a triangle and there is a line that goes through it, and the line is parallel to the base, then this side to this part is proportional to this side to this part. The converse says the opposite. It says if these are proportional, if AB, well, we don't have letters there, but if this is proportional to this, then the line is in fact parallel. The next thing that we learned is the two-transversal proportionality theorem, or corollary, which says if you have three or more parallel lines that are cut by two transversals, then the distances are proportional. So this distance divided by this distance is equal to this distance divided by this distance. And finally, we learned about the triangle angle bisector theorem, which says if I have a triangle and one of the angles is bisected, then distance A to B is equal to distance C to D. So A to B equals C to D. All right, this concludes the lesson.